Now we're going to look at exponential growth in the form of compound interest annually, semi-annually, quarterly, monthly, and daily. Let's start with an example. A savings certificate of $10,000 pays 6.5% annual interest, compounded annually. The question asks, what would be the equivalent monthly interest for this savings certificate? So they don't want to know the total amount of money you have after a year or after a month. The question's asking about interest. So to find interest, we're going to take the amount of money for the certificate, $10,000, times the percent interest. Remember, we need to take the percentage and change it to a decimal by moving the decimal place 2 places to the left, so 0.065. So I want to know what 6.5% of 10,000 is, so that way I can find how much interest I'll gain for a year. When I multiply these two numbers, I find that I'll get paid $650 in interest at the end of the year. The question asks, what would be the equivalent monthly interest? Since there are 12 months in 1 year, I could take the $650 and divide it by 12 to find out the amount of interest I would get each month. I find that I would get $54.17 each month if I divided the yearly interest by 12. But I could do it another way. Since there are 12 months in 1 year, if I were getting monthly interest, I would not be getting 6.5% each month, but I would be getting 1/12 of that amount. So instead of using 2 steps, I could find the equivalent monthly interest in 1 step by taking my $10,000 and multiplying by 6.5% divided by 12. This would tell me the monthly interest in 1 step. Type it into your calculator and try it out. All of the problems that we looked at in the first video were compounded annually, meaning we gained interest 1 time every year. So for annually, compounded interest, it's 1 period per year. Remember, compound interest is when a bank or a financial institute pays interest on both the principal and the interest that's earned. So annually, it's paid 1 time, once per year. So the interest rate is the full percentage every year. And the equation we use is the equation that we used in the first video. The amount of money that you have equals your principal or starting amount times 100% plus the percent of interest you're gaining. Remember to write that as a decimal. And we raise that amount to the t power. T, remember, is the number of times that it gains interest. Well, let's look at semi-annually. Semi refers to twice a year. You may hear it as biannually. So to calculate our interest rate per period, you're only going to get half of the interest rate each time that you're gaining interest. So we're going to take our percentage of interest and we're going to divide it by 2 because it's 2 times per year, which means we're going to gain interest every 6 months. Our equation would be like the one that we used in the first example in this video. We would have y, our total amount, equals our principal, A, times 1 plus 100% that we put in, plus our percentage of interest divided by 2, and our t value, How many times are we gaining interest each year? It's 2 times the number of years. So T times 2. Quarterly. A quarter, think 4 quarters in a dollar. So we're going to have 4 periods per year. When we calculate our interest rate per period, we'll take our percentage of interest and divide it by 4. You'll get 1/4 of the interest during each period, which means we will get our percentage 4 times a year, which is the same as gaining interest every 3 months. The equation would be y, our total amount of money, equals the principal or starting amount times 100% or 1 plus our percentage of interest divided by 4, and our exponent now will be the number of years that the money's in the bank or the financial institution times 4, because we get the interest 4 times each year. You try to fill in the monthly and daily rows. Pause the video and do that now. If the amount of money is compounded monthly, there are 12 months in a year, so there will be 12 periods each year. The interest rate is calculated by taking your percentage of interest divided by 12, because you get 1/12 of it each period, or 1/12 of the percent every month. Notice in the equation, it's your principal A, the amount you start with, times the quantity 1 plus the interest percentage divided by 12, and the power is T times 12, the number of years that the money is in the account times the 12 periods each year. For daily, there's usually 365 days in a year, so you'll take your percentage of interest, divide it by 365, which shows that you're getting interest every day. The equation will show your principal times 1 plus the percentage of interest divided by the 365 times each year, and your exponent will be 365 times the number of years it's in the account. Let's practice with an example. We have a $5,000 investment that's going to earn 5% interest. Write an equation and determine the balance after 5 years if the interest is compounded annually, semi-annually, quarterly, and monthly. So we can see that we're starting with $5,000. That's going to be your A value, your principal, the amount you start with. The 5% interest needs to be changed to a decimal. Move it 2 places to the left, you've got 0.05. Let's first write our equation using that information. We have our total amount equals our principal or starting amount of 5,000 times 100% plus the 5%. So 1 plus 0.05 raised to T, number of years. For annually, we'll use that equation, 5,000 times 1 plus the 5%, and our T value will be 5 years. We don't have to divide our interest rate because we're going to get the entire amount at the end of the year, and it's going to happen 5 times. So that's where the exponent comes in as a 5. Type that into your calculator and find the total amount of money. You should have found that your total amount of money, rounded to the nearest penny, will be $6,381.41. Please set up the equations for B, C, and D. Reference the table that we did in section 5 if you need help. Pause the video and do that now. If the interest is compounded semi-annually, it will happen twice a year. which means every 6 months you will get half of the interest rate. So I divided my 5% by 2, showing that each time it's getting half of it. Then I took my 5 years, which is T, and I times it by 2 because it's going to happen 2 times every year for 5 years. When we look at the quarterly, I took the 5% and divided it by 4 because quarterly means it's going to happen every 3 months or 4 times a year. Then I took T, the number of years, which is 5, and multiplied it by 4. I'm going to get 1/4 of the interest each time I gain interest, but I'm going to gain the interest 4 times for 5 years. Finally, let's take a look at monthly. There are 12 months in a year, so I'm going to get a 1/12 of the interest each time. So I take my 5% and divide it by 12. I add that to 100% of the money that I deposited, and my exponent shows that it's going to be invested for 5 years, but I'm going to gain interest 12 times each of those 5 years. Now I'd like you to pause the video and enter each of the amounts or the equations in for B, C, and D, and see if you can correctly come up with the amount of money that you will have after each of these situations. So pause the video and complete B, C, and D. If you correctly typed the equations into your calculator, you should have gotten the answers shown in red for each of the compound interest examples. Our final example says to write an equation for each situation. Then we're going to graph a sketch of the equations. So example A, there's $400 invested, earning 5% compounded annually. So the $400 will be our initial amount. It's going to earn 5%. We need to make that into a decimal, and it's important to note that it is compounded annually. Let's write our equations. We know that A is going to be the $400. We need to multiply that by 100% plus the 5%, and it needs to be written in a decimal. So we'll have 5% written as 0.05, and we'll add that to 100%, written as a decimal, is 1. When we add those two together, I'll multiply my $400 times 1.05, and it's compounded annually, so I'll raise that to the T power. Depending on how many years it's invested, that will then be able to be calculated to tell me the money I will have. You try B. Write the equation. Pause the video and do that now. For the second example, we have $100 invested, so that becomes our A term, and it's earning 100% annually. If we change 100% to a decimal, we get 1. Think about that. If your investment is earning 100% annually, then it's really doubling. So when I take the 100% of my earnings and add 100% to it, I end up with 200% as my growth. So in my final equation, y equals 100 times 2 to the T power, it's really showing me that the amount is going to double every year. Now we're going to sketch the graph of each equation. Use the A values as your y-intercept and the growth factors circled in blue to help you to sketch a rough graph of each equation. Pause the video and do that now. I know A will cross at 400 and be flatter, B will cross at 100 and will be steeper because it's doubling every year.